Hi, welcome back. This is Dr. Hadi and you are watching Medical Globe. Dear students, today I brought special topics for you. The topic names are number 1, biological oxidation, and within this biological oxidation we have 4 questions. Number 1 is electron transfer, number 2 is standard reduction potential, and number 3rd one is the conjugate redox pair. These 3 questions will be discussed, and most of the time will be given to standard reduction potential, because as per I know, most of the students feel a little bit confusion regarding this topic, reduction potential, because it is mixture of physics and chemistry both. So come to the topic of biological oxidation and electron transfer. Here is a wire, any conductor, and when you switch on the button, then something will start flowing into that in that wire. Actually, this is called as current. Yes, everyone knows very well about the current. So when the current flows inside the wire, it is actually the electron. These are the electrons that flow in the wire, and these flow of electrons are associated with the flow of energy. So when electrons is flowing, when electron is moving, it carries the energy. It is a kind of energy. We call it electrical energy. And when that current or electrical energy reaches to the bulb, any kind of device, it would give its energy to the bulb, and the bulb will be lighten up. So similar is the case in the living body. Inside the living body, again electron transfer takes place. Inside the cell, the energy is associated with electron transfer, and this whole almost whole chapter is involved with electron transfer, because it is also the name of bioenergetics, right? And biological oxidation, we are in the same chapter yet. So electron transfer, the concept of electron transfer is very necessary for all of us to understand. Here is a comparison between the living body and outside the living body. It may be a bulb, a fan, or an engine, whatever you can call it. Look at that. Here is a battery, and it has a positive terminal and a negative terminal, and when you connect a bulb with a battery with the help of external circuit or a wire, the current will start flowing from the negative terminal towards the positive terminal, and the electrons, when reach to the bulb, inside the bulb, the energy of the electrons, which we call the electrical energy or the current energy, that energy will be converted into the light energy. Yes, into the light energy, and some of the energy will be converted into heat as well. So the bulb is called here a transducer, because a transducer convert one form of energy into another form of energy A and energy B. So that was outside the living body, as we know very well. And now if you come to the living body, inside the living cell, we have again the electrons. We will see electrons flowing, but the question is that where the electrons will come from. Do we have any source of electrons? So the answer is yes, we have glucose, we have nutrients as well, all other nutrients, protein, lipids, different source of electrons we have, but for the convenience and simplicity, I have just written glucose here. So glucose is a source of electron. When you take in glucose, actually it is a source of electron. So the glucose will give its electron, and these electrons will start flowing, and they will reach to oxygen. Just like here, there was a path which has 2 points. From the one point, the electrons start flowing, and to another point, the electron reaches back. Similarly, in the body, there must be a source, an initial source from where the electrons start, and there must be another point where the electron will reach at the end. So we have oxygen at the end, and between these two, again there is a transducer. Just like here the bulb was transducer, it was converting the electrical energy into light energy. Here inside the living body also we have transducer, but they are called as enzyme and protein, and you will be given a very fantastic lecture on these proteins that convert one form of energy into another form of energy. You will be given a precise lecture on it. So during this electron transfer, the energy will be caught, will be released from the flowing electron, and that energy will be used inside the cell for different purposes. So in these two diagrams, in these two topics, we came to the conclusion that electron inside the living body, electrons associated with donor, electron donor, you will find electron donor, anything that give electron, and electron carrier, that carry electrons, you will find the electron carriers inside the living body, and of course you will find the electron acceptor that finally accept electron. Look, in all the topic of biological oxidation, you will find these three things: electron donor will be there, carrier will be there, and acceptor will be there. So that was a concept of electron transfer. Now here is another question topic: conjugate, redox pair, and redox reaction. Well, before we go to the redox reaction, what is reduction and oxidation? Come to the topic now. There is oxidizing agent and oxidation. Okay. Here we have any substance, right? We have any substance. For example, it has electron, and here we have another substance. Let's suppose this is A and this is B. Let's suppose that electron moves from A and it is gained by the substance B. So one substance has lost electron and the other has gained that electron. So what we call to this one who lost it, the electrons, that is called as oxidized. That is called as oxidized. And such kind of substance which release its electron, which give its electron to others, it will be called as reducing agent. Reducing agent. So means a reducing agent always oxidize itself. A reducing agent oxidize itself means a reducing agent give electrons to others. It reduces others and himself oxidized. So this is very clear concept. And now what about this B? B has gained electrons, so we will say B is reduced. B is reduced, and B can also be called as oxidizing agent. Oxidizing agent because it oxidizes other compounds and itself reduced. Here, this process in which a substance release electrons and which a substance give electron is called as oxidation, right? It's called as oxidation. The process in which a substance release its electron is called as oxidation. And reduction is again a process in which a substance gain electron, right? So electron release, oxidation, electron gain, reduction. Well, most of the students will be thinking about oxidation and reduction, that these can also be defined in other ways as well. Means addition of hydrogen is also called as reduction. If you give electron to some substance, this is called reduced. If it gets hydrogen, I suppose we have hydrogen, so if we give hydrogen to the compound, it is also called as reduced. So a reduced compound has relatively more hydrogen in this sense as well. The third definition of reducing is also that removal of oxygen. If this is a substance, it removes oxygen, it is also called as reduction. It means a reduced substance must be deficient in oxygen atom because it removes the oxygen. But in this topic, in today's lecture, we are not concerned with oxygen and hydrogen. We are importantly concerned with electron. So electron gain, reduction, electron loss, oxidation. Now here is the conjugate redox pair. Redox, if I write here redox, actually there are two words. One is red and ox. Red actually stands for reduction, ox stands for oxidation. Means if at any place we see reduction as well as oxidation, let's suppose we have A, it has lost its electron, A has lost its electron and A become A positive, and we have B will get the electron and it will become B negative. So A become oxidized and B become reduced. These two reactions where we can see oxidation as well as reduction, these two reactions are collectively called as redox reaction. So redox reaction is the combination of oxidation reaction and reduction reaction. And remember, most of the time you will see these two reactions together. If there is oxidation, at the same time there will be a reduction. Similar is the case in the biological system and inside a cell, where you can see a lot of redox reactions that we will provide the lecture in the upcoming ones. Here we have iron plus plus. Iron plus plus means it has lost 2 electrons, so it got 2 positive charge. When it loses one more electron, so it will become Fe plus plus plus, Fe3 positive charge. This is the electron that it has lost it. Here, if we come back, if we reverse that reaction, if we combine that electron with the iron, iron will become Fe plus 2. So from one side you can see Fe is losing its electron. So this is oxidation, right? And at another side, from the back side, iron is getting electron, so it becomes Fe plus 2. So this is reduction, right? Here we can see the reducing species here because it is going to reduce itself, and this is called the oxidizing species because it is going to oxidize itself. These two are called as conjugate redox pair. Pair is because they are two, so we will write them a slash between. One is the oxidizing species and other one is the reducing species. Such pair you will find a lot of such pairs. All of them will be called as conjugate redox pair. Okay, one more thing. Here we have iron and here we have a copper. And iron and copper. What happened? Iron loses its electron, it become Fe plus 3. Look at that. This is oxidized. Iron has oxidized. Where the electron will go, the electron will be given to the Cu plus 2. So when copper plus 2 gets 1 electron, it will become Cu plus 1 because copper is now reduced. Yes, you can see here. And iron has been oxidized. What I'm going to tell you, what I like to tell you, wherever you can see oxidation, at the same point you will see reduction, because the electron removed in the oxidation will be given to other species which will gain electron, so that will be called as reduction. So you will find these reactions side by side inside the living body. Now the third most important question is the standard reduction potential. I would like to raise all these now. This is another topic actually, that is measure of affinity for the electrons. Is a great question. It's a great question. If we say these are two person, and there is electron. For example, a student will feel a little bit confusion. He or she cannot decide whether the electron will be given to this person or to this person. Let's suppose A and B. So we use the word electron affinity. If the electrons are given to that person more strongly, we will say this person has great affinity for the electrons. And if the electron is given to that one, we will say this person has strong affinity for the electrons. Well, the reality is we don't have person here. We have a compound. Let's suppose we have compound A and B. In chemistry, every atom or molecule or a compound has to pass through 2 stages. Every molecule, atom or compound have to be in one of the 2 states. That is, either they will be having a tendency to gain electron or lose electron. These are the 2 states that every atom or molecule must pass through. If an atom can't get electron from someone, then it will lose its electron. Then it will be having the tendency to lose electron. And if an atom has the tendency to gain electron, then it will be very difficult for it to lose electron. Right? Then how we will find, this is now a most important question, how we will find that which atom or molecule has strong affinity to get electron and less affinity to get electron. This will be, we will understand this topic by the help of the electron standard reduction potential. So here is the word reduction potential. Reduction potential. Okay. We know the meaning of reduction. What is meant by reduction? A potential is a word that shows the ability, the power. Means the ability to get electron is called as reduction potential. The ability to get electrons. Let's suppose we have A, B, C. We have here electron. Let's suppose we have electron, and we see that the electron can reach only to this place, and B, electron can reach here, and C, in case of C, the electron can reach here. So being a student, what would you suggest? What would you think about this? Definitely we think that C has stronger affinity to get electron, and B lesser, and A more lesser affinity. So these are the relative affinities that we have. We have different molecules and atoms. All the atoms and molecules don't share electron equally. Different molecules share attract electron with different power, some more strong, other loosely, and other most very loosely. So in order to decide which atom or molecule attract electrons strongly and which less strongly, we will give you the concept of standard reduction potential or reference electrode first. Here we will compare one thing more. If you have a lot of students here sitting in the class, and I have to decide which student is more genius or which student is more intelligent. So I think it will be very difficult to decide which student absolutely is intelligent, less or more, until and unless we compare the student with another student, right? We cannot decide directly which student is more clever or intelligent. So what we have to do, we would invite one student, and the student will be standing here just in front of the board, and then slowly one student, we will invite other student to come, and we will compare that student with the reference student, and then we will decide as compared to this student, he or she is a little bit clever, intelligent, less intelligent, how much, and then slowly, gradually, all the other students will be given the chance to come and stand beside that reference student, and in this way we will be able to decide all those students which one is intelligent, more, less, or very much. Similarly, if we want to compare the reduction power of atom, we must compare those atoms with some reference, So in this case, we will choose a reference that is hydrogen atom, right? A hydrogen reduction potential is, means if you have hydrogen, means if it can get electron to become H, if there are two hydrogen, so you will get 2 electron and it will become H2, right? 8pH0, 8pH0. This has the value of electron potential, reduction potential is 0.00 volt. And what is volt? Volt is actually the unit of reduction potential. Yeah, we measure reduction potential in volt, just like we measure the current in volt. You might have seen this, the current is measured in volt. In ampere is the unit of current, and volt is the unit of voltage. So volt is also a word that is used with electron transfer in current. So definitely here also the topic is with electron transfer, so we would use the word volt as a unit of reduction potential. And you know, reduction potential is represented by that word E. E is the reduction potential, and if I just write just a small knot, it will be called as standard reduction potential, and if I just write a prime, then it will be called as standard reduction potential at the body pH. If you don't write this, means it is not at the body pH, it may be anywhere, any pH, but if you write it, it means that it is according to the physiological body pH. So means that the reduction potential of hydrogen is 0.000 volt, means it is very difficult for the hydrogen to get electrons to become H2. So this is our standard. Now we will compare all the other atoms or molecules, any atom or molecule that we have, we will compare them with this one. As compared to this reduction potential, all the others would either get electron or lose electron. So accordingly we will decide. Now we will set a half cell. You must have heard this word half cell. Here is, we have one half cell. Oh my god, I think we have less space here. There is a half cell and we provide hydrogen here, right? And there is another half cell. Here is our sample. Means it can be any atom, right? It can be any. But remember, any cell must contain its reducing species and oxidizing species. That must be present here. Suppose if there is Fe plus 2, then there must be Fe plus 3, right? This is one solution, and this is another solution. If we have here H plus ion, so there will also be H hydrogen molecule as well. So that is the oxidized species and this is the reducing species. That must be present in the two solution, in the two cell. Yes, this is called one half cell. This is called another half cell. Why they are called half cell? They are two cell, because when we connect these two solutions with the help of a wire external circuit, either one solution has to gain electron and other has to lose electron. So in one solution we will see oxidation and in other solution we will see reduction. That is why this is called one half cell. Means if oxidation occur here, so here reduction will occur. So the combination of oxidation and reduction is called redox reaction, because redox reaction stands for two reactions. One is the reduction and other one is the oxidation. So if I say this is the half reaction and this is the half reaction, so these two half reaction will make one complete reaction, redox reaction. That is why this is called one half cell and this is called another half cell. Okay, so we got two half cell. One is the reference solution cell, one is the reference that we have. Yes, and we already know the reduction potential of this cell. We already know, yes, that is 0.00 volt. Its reduction potential is 0.00 volt. Yeah, we know. Now we will connect these with each other. This is a wire, right? External circuit. And how would we find that electron is moving from one cell to other or not? We will use a physics device called as the galvanometer. A galvanometer is represented as G. It has a needle. It has number 0, 1, 2, 3 on the right side, 0, 1, 2, 3 on the left side, right? And we have a needle just in the middle. This needle has the ability to move on the right side and to move on the left side. Depends upon the current. If the current is moving from left to the right, the needle will be diverted in one direction, and if the current is moving in the other direction, the needle will move in the opposite direction. So the needle direction will tell us the flow of current. And now there is one thing more. In between these two solutions, we will place a small device, another pipe, which is called as a salt bridge. Yeah. What is the function of the salt bridge? It contains potassium chloride it will prevent the accumulation of charges in both the cells. It will counteract the opposite charges. Mean if here positive charges are increasing, so there will be negative charges will be increased. So what it do, because of this salt bridge, neither the positive charge will be increased here, neither the negative charges will be increased here. So we will be having a constant flow of electrons. So the main purpose of salt bridge is to prevent the charge accumulation in both the cells. Okay, so this was the salt bridge. When you connect these two cells, then any one of the possibility will take place. Either the electron will start flowing from this cell towards this cell, or the electron will start flowing from this cell towards that cell. Depends upon which cell will lose electron in comparison with the standard, and which cell gain electron. In those cases, mostly we will see that the electron will start flowing here from that half cell with standard difference. They will come, because it is a current, so the needle will be deviated to any one direction, telling us that there is current in the wire. And if the digit here comes to 0.5, 3, 4, 1, 2, or any case, so that will be also, that will tell us the reduction potential as well, because we can read how much reduction potential. It is 1.5 volt, 0.3 volt, or any number we will get from this galvanometer, right? And then the electron will reach here to that cell. Means that here oxidation took place and here reduction took place. So as I told you, any one will lose electron and other will gain electron. So the one which gets electron with more stronger affinity will be given a positive. Means in case of this solution, the reduction potential will be given a positive sign. A positive sign means that this solution has more power than the standard one, so there is a positive sign. And if you find a negative sign with some atom or molecule, it means that this has less affinity to get electron, right? And remember one thing more, if I say that it has positive reduction potential, means it can gain electron, so it is possible that in comparison to other molecule, this will lose electron, and in this case it will be negative. So the positive and negative are decided whether it will get electron or lose electron with the reference electrode. Now let's suppose I placed a solution A here. It contained any sample A, and I noticed that the electrode potential in this case is 3 volt, right? And then I placed here another solution which is called as B. In this case, the electrode potential is 2 volt in case of B. So in case of A, 3 volt. In case of B, it is 2 volt. Now what is the purpose of this? One solution A has reduction potential plus 3 volt, other has plus 2 volt. What is the purpose of this? It means that if someday we connect A with B, if we connect A with B through a wire and galvanometer, what will happen? In this case, we know very well that the reduction potential of A is 3 more than B. So what will happen? You can decide. Yes, the electron will start from B because B has lower reduction potential as compared to A. So the electron will move from B and towards A. This will tell us that in this case A will reduce and B will be oxidized. So this was all about the reduction potential, and standard word is given because when we use the word standard, it means we are performing our experiment at some specific conditions. At specific condition means the amount of the both the half cell must be 1 molar. The amount must be 1 molar. If it is not 1 molar, so you cannot use the word standard. And the pressure must be 101 kilopascal. Yes, this must be the pressure, and temperature must be of 25 degrees centigrade or 298 Kelvin, and pH is 0. Right. So in this condition, we will write E naught, standard reduction potential. And inside books, you will find E naught and a prime also there. Prime means that now you are performing that experiment in the living body according to the living body condition. Living body condition, the pH is not 0, the pH is 7. So if you perform this at pH 7 and all the other conditions are constant, pH is 7, then there will be a prime as well, means standard reduction potential at physiological pH. Now you will see in the book there are a lot of pairs. Yeah, there are a lot of pairs. One example is that we have that is oxygen. This means one oxygen atom, and there are 2 hydrogen ions and 2 electrons. These will be given and will become H2O, right? This, yeah, oxygen, hydrogen, electron, and become H2O. If you see in front of this equation, you will find minus 0.816. E naught minus 0.816 volt. So what is mean by this negative sign? Means that this reaction has its reduction potential of minus 0.816. Means this reaction has very less affinity for the electron to get, because it is in negative. The more negative means the lesser affinity, and the more positive means greater affinity. This is a reaction. And every reaction has its reduction potential. Every reaction which involve electron transfer has a reduction potential, and some have these values in negative values, other have in positive signs. So we will decide accordingly, because each of this value is given through this experiment. Remember, each of these given has been, this value is given through that experiment, right? So we can not only determine the reduction potential of an atom or an ion, but we can determine the reduction potential of a complete reaction where oxidation and reduction takes place. Inside the living body, we have thousands of reactions, and every reduction which involves reduction reaction, which involves redox reaction, has their own standard reduction potential. Now the last is, what is the importance of this reduction potential? What is the importance of this reduction potential? The importance of the reduction potential is that we can determine the free energy, and I have already given a lecture on the free energy, right? So we can determine the free energy of a reaction if we know. Look, that is delta G naught, means the standard free energy of an reaction is equal to minus N and Faradays constant, and this is delta E naught. This is what? This is standard reduction potential, and if delta comes, means change in the standard reduction potential. I told you, every reaction has this value. And this is called Faradays constant. Its value is always constant, that is 96.5 kilojoule per volt, right? This is the constant value of Faraday's constant, and n is the number of electrons. You know that whenever there is a reaction, there must be electrons, transfer. 1 electron, 2 electron, 3 electron, whatever number of electrons we have, we'll just put the number of electron here. Faraday's constant is always constant, and we also know that every reaction has a standard reduction potential. So we will put the values here, and whatever answer comes will be the free energy. And if that free energy comes with positive sign, means that reaction is endothermic, not spontaneous. And if that value comes in negative sign, means this is exothermic and spontaneous reaction. So we today discovered a relation between the free energy and the standard reduction potential as well. I hope you understand the whole lecture. That was on student demand. I hope they understand. If you understand, have a thumb up, and we'll see you in the next lecture, and keep smiling on your face. Thank you and bye bye.